So last year I started, I think I might have been the only remote execution presentation. So this year I had, and obviously we have a ton of remote execution presentations all day going on, including both Google internal and third party. So I decided to buck the trend and give you an opportunity to hear a little bit about a war story associated with how we at Uber, specifically at the ATG, moved from an existing build system into Bazel, and to give you some impression of what the challenges and what the costs were associated with doing that. This is also going to have a little bit of a community slant. What I want to preface the whole thing with is that the Bazel community at large, including David, and including specifically members of the remote execution team, because they've been working with me over the past year to develop Build Farm and to develop other tools, they have all been immensely helpful in terms of both weeding out problems, dealing with issues, getting my code accepted into the Bazel core repo, and obviously reviewing things inside of Build Farm. So number one, I want to give them a round of applause because they're great. So our objective here in this talk is to try to give you some sense of what we went through to get Bazel adopted. Sort of the hammers and the chisels that we applied to that situation, and essentially what we came up with in terms of cost for maintaining that going forward. And we have an ongoing cost. We have the duty of maintaining our significant number of developers with their significant number of builds on a daily basis, and specifically, we wanted to contribute that stuff back to Bazel because we utilize this tool. We want that stuff to be persistent, and we also would like to reduce that burden over time in terms of maintaining that software. So we're going to go through a little bit of discussion today. I apologize, my slides aren't nearly as nicely formatted or as brightly accentuated as everybody else's, but we'll cover a couple of these topics. I'm not even going to read them off. The first is our use case. At the ATG, we have a large build with a comparably large set of third-party input dependencies. And this presented its own problems. Most notably from the start, we utilized local repository. If anybody is using local repository today, it just means to pull things from your local environment on your box. We were subject to the installation rules of our distribution. And that meant that all of those things were contributing into our action definitions. We change a whole lot of our code base every day. A lot of this hopefully sounds similar to your project. It certainly is similar to the situation at Google. We use C++. We use a lot of C++. There are several specific permutations that we want to support in terms of configuration of our compiler and our linker. And we want to be able to specify them at will. We want to be able to add debug flags to specific places. We want to be able to add profiling and code coverage and static analysis and dynamic analysis and that sort of thing to our build, other instrumentation, and utilize aspects and other tools to discover our action graph in different ways on an ongoing basis. We have a desire to make our build faster. The tacit understanding there is that we have an addiction to building all. If you don't have an addiction to building all, congratulations, you've broken yourself of a great or a terrible habit very early on in your process. We also wanted to make our build more self-contained. Using those local repositories, we were subject to constant changes associated with even well-natured upgrades associated with our users. If our CI machines fell out of compliance with our local development machines, there was the immediate capacity for us to suddenly generate an entirely new build. If an SSL header changed, if a curl implementation changed. Oh, sorry. And the last thing is that we wanted our tests to be cacheable, our test results to be cacheable. This is a big thing for us, not just because we want to take our tests and not have to rerun them again, but we want nothing but to add more and more and more tests to our system. We want to make sure that we are safe in every regard to what we're developing. And the only way to do that is to add testing layers at each individual level and to be able to prove that that system works. And the only way that we're going to be able to trust a caching system for tests is if we can prove that they change when the code changes. So our prior art looks like a terrible set of tools. We utilize CMake and Ninja. That means that we were generating Ninja files from our CMake build definitions. We were only building all. There was very little support baked in for building individual targets. In fact, I asked some of the senior engineers whenever I first came onto the project over 2.5 years ago how to build just one thing, and nobody had any idea. We implemented several distinct rules for a custom IDL. We had rules for build sequencing, which means that we were putting together rules that staged our build in different phases, and nothing was able to cross in between those two different phases. We also had a whole bunch of rule type glob dependencies, and if that doesn't mean anything to you, think I need to generate every single proto definition across my entire build tree, and I now want to make a rule that can depend on that having occurred. Very similar activities happen here, and these are obvious bottlenecks, not just to local execution, but the idea that we now have to have a full manifest of everything, and every build has to be completed with an all target, because you can't correctly identify the glob set without having identified all of the targets in the system. We utilize Ccache. This, if you're not familiar with it, is a tool for caching on the local file system for compiles only compilation results, and they also happen to cache makefile dependency outputs. And this is preprocessor based, which means that you have to perform the preprocess, which is a very I/O intensive operation. It means that you have to scan everything in your system in order to calculate a key that this system uses to pull your outputs out of and keep track of. Similarly, we also used Ice Cream, which is a preprocessor-based remote transport system and executed in a pool of machines that were highly available. We actually used a shared pool amongst our developers, and that caused a great bit of consternation when suddenly my usage spiked on your desktop because we were compiling something unique or interesting. So I joined up in May 2016 when Bazel was at the heady revision, I believe, of 0.32, and said, let's get it working. Ice Cream is utilizing something that is over the network. It happened to be in the lucky case that it was communicating over a FIFO, which meant it needed access to a particular file on the file system to discuss its operations with a daemon to distribute out to the system. And we had to break through sandboxing. So that was actually my first Bazel change, was publishing an execution requirements for networking. These local resources won't work for estimation. Does anyone remember the local resources estimation system inside of Bazel, where it said, no, you've definitely only got, 250 of CPU. I don't know what 250 was, but I certainly had more than it. And especially I had more than it whenever I split out and did my remote execution. So that stuff had to go. You'll notice throughout my presentation that I've got a lot of links here. I really encourage you to download these slides because almost everything points off to either an issue or a change or something that's come up as a result of doing this transition. But our linking is completely different. We needed to utilize controls for the file names themselves so that we could output foo.so that somebody else could depend upon without the lib prefix, or we needed to ensure that so names got injected into our dynamic libraries, or we needed to make sure that our transitive libraries got loaded up into our .sos, and so on and so forth. Wait a minute. The header discovery system, include pruning, doesn't work out of the box for Bazel, so we had to go fix that. And then the last thing is that our users really, really wanted to produce a manifest list of compile commands.json so that they could plug that into their IDEs, so we got to put that into the internals of Bazel itself. If you're thinking that these represent a whole bunch of different changes that we wanted to contribute back to the system, you are correct. So it's worth looking at the current contribution process and what it was before. So I got a link here for the process itself. The last modification for this was back in July, so at least we're tweaking this over time. We've switched over as a community from Garrett to GitHub for reviews. I'm really happy with that. Garrett was a little bit out of sync, especially with the other projects that I was working on. And on this system, a Bazel team member which is identified in the documentation, and then I've sort of associated that this has to be a core contributor, performs a review. And there's a sort of blurb there that came out from this thing that describes the way in which things go into the Bazel system, which means you put up the GitHub pull request, that gets accepted by someone, it gets merged into something internal that I don't know anything about, and then it pops out with a Piper Rev ID, I don't know what that is, and is emitted by a system called Capybara and put into the public GitHub repo, and your code is available. This contribution process also includes a whole bunch of really good stuff which we sort of ignored on our first pass. And I don't even know if it was available, but for now, if you're looking to go and try and build your own Bazel and make your own fork, this is the best way to get started doing it. It describes setting up your coding environment, being able to build your Bazel, trying to debug your Bazel, and then how to find the code that, that means something to you. I got pinged by one of my colleagues, Jacob, the other day. He sort of asked me how I seem to know everything about where to find something. He gets stuck in 5 different directions inside of Bazel, trying to understand where something came from. And I said that it's become second nature to me. That these layouts and these descriptions are very intuitive and tend to lead, for me at least, to the ability to properly deduce at least where something could be coming from. I've also gotten really good at reading stack traces. The other side of the contribution policy is this governance policy, which has fallen a little bit further out of date. It hasn't been updated since 2016, so at least it's since I've been at Uber. But it's a restatement of a lot of what goes into the contribution guidelines. But it also makes some other clarifications that I don't really understand even to this day. All core contributors work for Google. And the hope is that that changed over time. When this was written, I don't know, I'm certain that everybody worked for Google. I don't exactly know what the state is today because we have the core contributors list. I'll put it to David. Is anybody working for Ulf? Is anybody on the core contributor list not working for Google? Okay, cool. Sorry, I didn't mean to make this audience participation thing, but I want to check my facts. But there's a mission statement at the bottom that says that we will move towards an open governance model where multiple parties have commit access, rollback rights, and can provide explicit support for our features or rules. I'm not going to offer any commentary on that. These are all sort of stated facts, and this is what we were using to guide our behavior associated with how we interacted with the Bazel community and what we hoped that we'd be able to get out of them. The release process itself just says we regularly publish releases of Bazel. Aside from that, there's a new policy that was adopted last year, if you're not familiar with it, which is that the releases come out every single month on or about the start of the first month, and that patch releases come out as a result of bug fixes or minor problems that occur as a result of that release. So how we got our PRs accepted. We want to give everyone who wants to contribute to Bazel advice and or anyone who wants to maintain their own fork advice associated with how to get this stuff out of your responsibility and back up into the Bazel ecosystem. We want to follow the policy for the most part. When the policy was available, there were a little bit of tweaks, there were a little bit of odd things. Essentially, I would recommend to you that any part of the policy or any part of the procedure that becomes cumbersome, that you take the opportunity to talk with the Bazel team about. This is how, as far as I know, the reviews on GitHub started. This is how, as far as I know, we got into discussions about community contributions at large in terms of opinion and in terms of proposals, that sort of thing. We also kept things small, and that had some good results. We filed issues to keep track of what we were encountering, which meant that we had a public record of exactly what went wrong, hopefully as close to the master revision as we got it. And these might seem like sort of trivial things, but when you're sort of swamped and subsumed by the idea of migrating a very large code base, a lot of these good procedures were hard to discover, or at least hard to hard to execute the rigorously good practices associated with this. So some of the other things that we tried that may not be detailed in the governance or the contribution policy were that we tried explicitly communicating with the team members or the stakeholders associated with each of these projects and tried to let them know, I'm having this issue. I've filed this particular thing on GitHub. I want to see some results about something about this. I want to feel some comfort associated with that that the problem exists, that we're getting somewhere on it, or that it's in or out of scope for a particular release. Typically, I pinged issues or PRs after about a week of silence and got some nice results as a result of that. I'm going to breeze through a couple of these case studies. They're kind of silly. The last change that I made to the Bazel repo is I improved a request ID error message. This thing was saying that a build request ID was a valid UUID, and that was the error printed when it wasn't a valid UUID. I pushed that out locally on September 19th. I got a looks good to me review, and then I had the entire thing closed out within hours. It was closed the same day. The next thing that I did, or rather another nice discussion that we had here, was a repository cache issue, where whenever you had a download interrupted associated with your with a remote cache or with a repository cache asset, it broke in perpetuity until your repository cache was deleted. It broke operations and wasn't able to continue on from that. We filed an issue. We got some results. Everything sort of got in there. But these case studies are sort of progressing down a path of, well, we didn't really get a response, but we tried to do some things out of band. Here's what I recommend. Make sure that you stay on top of these things. The other issue that we encountered in terms of an action cache shutdown regression test, let's see. We got a fix for this put in. We insisted that we have include pruning work. This was a larger effort for the problem that I discussed earlier where we couldn't successfully get include pruning out of C++. We eventually got the entire response from the Bazel team to center on the right issues. If you take a look at any of these issues and descriptions, we go through a whole bunch of different scenarios where we describe, well, is this a problem? Is this not a problem? Have we found a major breaking bug inside of Bazel? It got fixed eventually. Please take a look at the summaries there. So that was how we successfully got our stuff applied. Here's how we failed to do this. And the trends here are essentially we didn't document our process. We did not work on the head of master. We did not verify our changes associated with master. We provided sort of partial solutions to problems. And now I sort of get into areas where I don't necessarily think that failure was good or bad, but it probably could have been avoided if we had had more collaboration in terms of getting acceptance from the Bazel team, getting some involvement from them. We wanted to provide either our own proposals for a problem that we encountered and have some sentiment of contribution in that manner, or we had problems that for which we proposed things and they just sort of fell out of date. Hopefully we'll get through this on the case study quick. CC Inc. library, so that dates this this submission itself. We ended up with a stale situation here where we couldn't properly get this determined. Essentially, we filed an issue where a CC Inc. library could leave things around, and we went back and forth on what happened here. We got some core members of the Bazel team involved, and we eventually decided that, the Bazel team eventually decided that the desirable solution would be a slightly different one that was provided internally. We also had a Garrett code review on here, so again, we're going back in terms of what we're doing. But essentially, the time spent on the pull request, where I made it a little bit more complicated than it needed to be, was wasted because an upstream provided solution was adopted, but maybe the pull request was only accepted because, or maybe the upstream solution was only provided because I had something up there ready to go. I had another situation where we wanted to add a parameter. We got no issue presented. That is to say, we didn't present an issue associated with this. We didn't properly provide our use case. The best advice that I can give anyone for this stuff is define your use case, define exactly how it's going to work, provide a minimal description of why it's vital to your operation, and hopefully you'll be able to get the help associated with your issue and the acceptance associated with it. And the last thing that I'm going to be talking about is our only proposed change to now, well, I'll say it's Skylark because at the time it was Skylark. We made a request to take parameters through rule definitions and transform them into multiple things that were expanded in rule implementations. If that doesn't mean anything to you, don't worry about it. But there were some pretty vehement opposition to this a couple times, having posted the proposal. And we eventually came down to something where we were referred to an output maps madness document that was originally written by Dimitri. So thanks, Dimitri. And my only concern here is that sometimes there seems to be a dissonance associated with a request's validity and the fact that, well, we've got crashing behavior or we've got behavior that you insist is bad but can't be moved in or out of the Bazel ecosystem. So the last part about this is the fact that we got remote execution and remote caching changes, and I won't talk too much about like how or why that went in, except for the fact that we represented something that was, we were building a tool in terms of build farm that represented the only endpoint that was testing a very fresh set of code inside of Bazel. And we had the opportunity to rapidly iterate, talking with the remote APIs team inside of Google and the Bazel team itself to try to improve the situation in a world where the build farm, or sorry, the remote execution endpoint wasn't as reliable, my endpoint. We had several patch releases associated with this, and we got these accepted fairly easily. Most of this was through discussions out of band with other engineers. We had a couple of issues posted, but in general, we were starting to follow really good practices as we went along with this. All right, so back in our office, we were doing a whole bunch of changes all on our own. We were gearing up for remote cache internally. We did a whole bunch of changes associated with keeping track of those different ecosystems in terms of Ccache and Ice Cream for executions. We put together some internal stuff for the compile commands. We removed our sandbox module because it was representing a hang in terms of NFS. And what I feel about these patches is, number one, I wanted to make them available publicly, so we put them up on a GitHub page. Which is referred to at the end of this process. But in general, we didn't know whether we could get them accepted. They seemed to be sort of anathema to fixing tools and fixing the environments, but they had to be made so that we could get them to work. We tried to ride the release wave here, meaning we took all of these custom patches that we were maintaining, and we had about 64 or 65 of them at a time, and we tried to ride each one of the independent releases. Now, to put this into perspective, I'm developing Build Farm full-time as this is going on, and we're trying to improve the build performance of a whole bunch of different teams inside of the ATG. And at the same time, we've also got monthly release cycles coming in. So what we ended up doing was splitting our independent changes into several different branches. We rebased each one of these branch sets on a minor release, and then we took all of the build results after we had properly done the rebase, and we ensured that all of our action cache keys mapped so that when we transitioned from one side to the other, we knew that we didn't break, or rather, we could test in isolation all of the unique behavior changes that we had in addition to all of the changes that had come in from upstream. And we did the performance equivalence for the same stuff. We made sure that our builds were not taking significantly longer than the previously implemented versions builds. Along the way, these numbers reflect essentially where we went, where we started out, 031, to our adoption build wide at the ATG with 0.4.2 all the way through 0.16. We've done one incremental release after another to successfully adopt everything that has been accepted through 16. We've dealt with a lot of C++ restructuring that's coming from upstream. And we also switched completely to executing with build farm internally and using a tool called Bazel cache to offer a local copy, local facsimile of the C cache behavior. Things that we're interested in coming up with is that we need some parity associated with the, we need a CI system that ensures that this happens, and we want to try and automate this as much as possible. Because we've taken probably 2 weeks of every single developer on our team's time up in trying to make these things work. So where are we now? We have only extremely custom changes. We have backports from master. We've managed to throw away all the C cache stuff and as much linking as we possibly could. We have about 39 individual patches, about 1,000 lines of diff context. It really is a small number in terms of the whole Bazel ecosystem. And we're anxious for C++ changes associated with sandwiching and doing other cool things. Hopefully we can get rid of some of our linking changes. We really want to get to a vanilla system that allows us to interact and follow along with, for instance, the RBE SLA of two minor versions and other documentation pieces that are available. Not having fresh documentation or having issues with that sort of thing tend to lead to unhappy developers who can't use a good reference point to describe what they're doing. So what did it cost? It cost every single, I shouldn't say every single, a single developer 2 weeks to do almost every single one of our upgrades. We are now slightly out of spec with Bazel build. For the things and points at which this mattered, I have been contacted and I've been asked about why doesn't this happen, why doesn't this match the documentation? And the worst part about this, I think, is at the bottom where the yield on the proposals and the PRs and the issues got lower. Like it dramatically dropped off as we were unable to keep up with that scenario where upstream was changing or there was an entire module that was thrown away with upstream. Where we had applied effort before, we weren't able to capture it later. And since I don't necessarily want to be in the business of maintaining a fork of Bazel publicly and trying to compete with the entire Google infrastructure, I want to leverage that, and I want my efforts to count. So the only way to do that is to save myself effort from having put something out in the first place. Save myself effort on writing the proposal that isn't going to get accepted, or the PR that isn't going to get adopted, or the issue that isn't going to get kept track of. So that's my last slide, or my last couple of slides, and I hope that, again, the community and the Bazel team can look on this as what I want the rest of people using Bazel to know that we took on, as well as what it is probably going to cost if you try to maintain your own fork. The community and the Bazel team are doing great at leveraging all of the water wheels at Google. You guys are phenomenal. You produce phenomenal code. I can't even come close to providing the same level of support that your tech writers and your language specialists and the performance implications associated with Bazel changes provide. The advice that we've gotten on proposals and the PR and the responses to PRs and the chats that they've had, everyone comes to me with something after I bring up the slightest topic. I got mauled by talking about action keys for about 15 minutes after I brought it up before, because they want to help and they want to know and they want to provide all of that ability. There is very low friction associated with communicating with the team and with the Bazel group at large, and I hope that that continues. What can we do better? What can the community do better to work with one another to either get these things adopted, to reduce the need to support this, to reduce the cost associated with forking these things? I think that we can move towards the diversity and specifically inclusion goals of including the rest of the community on the open governance model. I think that we can probably make some steps towards that within the year. meaning set a goal, set a milepost associated with we have one core contributor from not Google, or we meet the goal associated with what was specified there, and that the gold standard from this, and this wasn't actually my quote, I'm not even going to bother saying who it was, but somebody said to me, the gold standard for how this should be measured is you don't get any advantages from working on Google for contributing to Bazel. So the last couple of principles, yeah, we want attribution for all changes. Dimitri's done a great job and told me that we're going to have issues for every single thing that comes in. I'm looking forward to that. I'm also looking forward to some collaborative community project planning associated with what we do. I'm already participating in that in terms of some proposals for the Bazel client. I like this group. I love this tool. I love interacting with it, and I can't wait to see what we're going to do in the next year.